Hey everyone, as you already know, I am Anirudh here, a student of Indian Institute of Technology, Kharagpur. I am a third year undergraduate student of the Department of Computer Science and Engineering, enrolled in the course, right? And this is part 3 of your differential equations chapter where I'll be solving this related, right? So since this is the end chapter exercises, I'm not going to be providing a brief or anything. I'm just going to directly go with the exercise. So question number 1 in miscellaneous. It's for each of the differential equations given below, indicate the order degree, right? Right. First of all, over here, I hope you all remember what I've told you about the order of the degree, right? Because if you don't, then you're far worse at it, right? So first question, part 1, we have y double dash plus 5x is a y dash the whole square minus 6y equals log x, right? Very easy to see that since you have a y double dash term over here, the order is 2 and the degree is 1, right? And you have to basically check that this equation is linear and there is no sign of a differential term. If this is polynomial in nature, we can directly say that the order is defined and the order is 2 degree. Going to the second question then, second subpart. Says there is y dash cube minus 4y dash squared plus 7y equals sin x, right? There's no sign of a differential term. This is polynomial in nature, and so your order is 1, your degree is 3, right? Third equation, you can see that there's a sign of a differential term. So this is non-polynomial in nature. So the degree is not defined, right? Because if you expand the sign term, what you're going to get is basically y d4y by dx4 minus this is an infinite expansion, right? So you're going to get something like 1 minus y3 by this will be an infinite expansion of y3 terms, right? Minus y3 cubed by 3 factorial plus y3 power 5 by 5 factorial minus blah 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 till infinity, right? So you can basically see that the degree is not really well defined because you have an infinite expansion, right? So you have basically your order being 4 and your degree being not defined, right? Going to question number 2. For each of the exercises given below is a solution of the corresponding differential equation, right? This is also pretty simple. This is your second exercise. So basically you have y equals a e power x plus b e power minus x plus x squared, and is given for the equation x y double dash plus 2y dash minus xy plus x squared minus 2, right? On that, right? So basically, yeah, since you have a y double dash and a y dash term, differentiate this equation twice, right? Y dash is easy to find, is basically a e power x minus b minus x plus 2x, right? And y double dash on the other hand is basically a e x plus b e minus x plus 2, right? And so your differential equation then becomes ax e power x plus bx e minus x plus 2x plus 2 times of this, that is 2a e power x minus 2b e power minus x plus 4x, right? Minus x times y, that is ax e power x. This is ax e power x minus bx e power minus x minus 2x squared, wait, minus 1x squared, right? Minus x squared plus x squared minus 2, right? This is basically the differential equation. Say this is say this is D, then basically D is equivalent to this form, right? I'm basically substituting y double dash, y dash, and y over here, right? This is the LHS. This is your LHS of, right? So you can basically see that ax e power x terms cancel out. The bx e power minus x terms cancel out. Your x square terms cancel out. And you have a plus 6x over here. Just a minute. So plus 4x. So plus 2. So you have a plus 6x over here, right? Wait a minute. What a minute. This is x cubed. This is x cubed, right? And this is the plus x squared is still the x, right? Okay. All right. All right. All right. You can't do this way since you have two arbitrary constants. Since you have these two arbitrary constants, you can't really go substitute this directly and then find it. Because these arbitrary constants work in a way such that the whole expression cancels out actually, right? So if you don't know the value of these arbitrary constants, then what you can do is basically, since you have found the differential forms over here, wait a minute, sure, all right, all right, right. So what you can do is basically you have these forms and you know what the values of a and b are, a per x and b per minus x are given, right? So basically what we have here is the fact that this, wait a minute, wait a moment, is there a printing mistake over here? I think there's a printing mistake over here. This over here should be xy, not wrong, right? It won't ever satisfy the equation. So basically, since this is xy equals a per x plus b per minus x plus x, now what we do is differentiate once, we get x y dash plus y equaling a per x minus b per minus x plus 2x, right? This is the first differential, differentiating once from this, right? Differentiating another time, we get x y double dash plus 2y dash equals a e per x plus b per minus x plus 2, right? Don't mind this. Don't mind this. This is the previous calculation. Right. So what we get from here is an equation relating this, right? And you can see that what this is, right? This term is basically xy minus x squared, right? A e per x plus b e per minus x. This is basically this minus this. So we have the equation x y double dash plus 2y dash equals xy minus x squared plus 2, or x y double dash plus 2y dash minus xy plus x squared minus 2 equals 0. And that is your required differential equation, right? Therefore, verify. Right. Going to the second subpart. Similar way, y equals e per x times a cos x plus b sin x. Given that the differential equation is y double dash minus 2y dash plus 2y equals 0. Right? Similar steps. Yeah. We take the first differential. Y dash is a per x times this is what? A cos x plus b sin x, plus since this e per x has the same e per x as its differential coefficient, I'm just directly multiplying it. I'm just directly taking common. I'm not really writing all the steps. All right. So there's e per x into a cos x plus b sin x plus e per x into differential of a cos x plus b sin x. That is basically b cos x minus a sin x, right? And y double dash is going to be e per x times this whole thing, that is a plus b times cos x plus b minus a times sin x plus b minus a times cos x minus a plus b times sin x, right? Because cos x, the differential of cos x is minus sin, differential of sin is plus cos. So we basically have plus b minus a cos x and minus of a plus b sin x, right? So we basically have this a going off, and over here, this is this b going off, right? So we are basically left with y double dash equaling e power x into 2b cos x minus 2a sin x, right? Over here, you know, see, right? This is basically, this term is basically twice of y dash minus y, right? Because you can see over here, y dash is basically this. This is y. This is the part of term that corresponds to y minus, and this is the term that's over here, right? So basically, b cos x minus a sin x twice is y dash minus y into 2, right? This is y dash. Therefore, we have the equation y double dash equals 2 times y dash minus y, or you have the differential equation y dash, y double dash minus 2y dash plus y plus 2y equals 0, right? And that is the given differential equation. Therefore, is true, verified, right? Your third subpart is basically y equals x sine of 3x, given the differential equation, y double dash plus 9y minus 6 cos of 3x equals 0, right? From here, you have the fact that y dash is equal to sine 3x plus 3x cos 3x, right? Therefore, y double dash is going to be 3 cos 3x plus 3 cos 3x minus 9y, right? Because it's going to be 9 of minus 9x sine 3x. That is basically y, right? So you have y double dash equals 6 cos of 3x minus 9y, or basically you have the differential equation y double dash plus 9y minus 6 cos 3x equals 0. Since that is a given differential equation, you basically have this to be correct and you are verified, right? And the last question of the second, or the last part of the second, that's x squared equals 2y squared log y, right? Given the differential equation, x squared plus y squared times y dash equals xy, right? I've taken the liberty to rewrite this differential equation somewhat because they are basically equivalent forms, right? So don't get confused with that. And this is a bracket, this is not exactly a modulus. All right. So from here again, we are going to deal with the first differential, right? Differentiating this once, you basically get 2x equaling 4y ln y plus 2y squared by y is 2y into y dash. Yeah. Removing this 2, you basically have here a 2 and here a 1. So you basically have the equation x equals 2y ln y plus y times y dash, right? And now, since you have x squared is 2y squared ln y, I'm going to multiply this whole thing by x, right? So basically, x squared is going to be equal to, wait, no, not x squared. Since 2y squared ln y is going to be x squared, right? I'm going to multiply this whole thing by y, not by x, right? So we have y times x is equal to y dash times 2y squared ln y plus y squared, right? Since this is x squared, this is basically equal to y dash times x squared plus y squared, right? Therefore, you have the equation y dash times x squared plus y squared is equal to x squared. And that is a given differential equation rewritten, therefore it is verified. All right. So going to the third question. Form the differential equation representing the family of curves given by x minus a the whole square minus 4 plus 2x squared equals a squared. X minus a the whole square plus 2y squared equals a squared. Find out what curve, what this family of curves actually represent, right? That is a task I'm giving you. The answer is pretty simple and we've already done it, if I'm not wrong. So you can actually see the previous questions if you want to, or else you can just think on it for a little while and maybe draw it out and check what this family of curves actually represents. Right? I'll form the differential equation, right? So this is pretty easy. Written in expanded form, this is basically x squared minus 2x plus 2a squared, right? Because it's plus a squared and that plus a squared is cancelled, becomes 0, right? So differentiating it once, you basically get 2x minus 2a plus 4y y dash is equal to 0. Or basically that 2a is going to be equal to 2x plus 4y times y dash, right? Therefore, you have the differential equation 2y squared plus x squared is equal to 4x squared, right, plus 4x y dash, right? Or this is 3. Therefore, y dash is equal to 2y squared minus 3x squared. 2y squared minus 3x squared divided by 4, right? Wait a sec. I've done a mistake. No. Yeah, I've done a mistake. Oh, here it's not 4, it's 2. So this is basically 1x squared, not 3. Right, this is 2x squared because I'm substituting 2a directly, right? So it's 2x. 2ax is basically, this implies 2ax is basically this times x, that is 4x, wait, again with the 4. I'm stuck on 4. It's 2x squared plus 4xy y dash, right? Substituting that over here, right? I'm basically bringing this 2x to the side and I'm rewriting it over here. So therefore 2y squared plus x squared is 2x squared plus 4xy y dash. And so you have this x squared and this 2 going off. So basically bring this to the other side and I rewrite this as y dash equals 2y squared minus x squared divided by 4x squared, right? And that is the required differential equation that represents the family of curves of ellipses that are of this, right? Now question number 4. Prove that x square minus y square equals c times x square plus y square the whole square. The general solution of differential equation this, where c is a parameter. Alright, so we have the differential equation x cubed minus 3xy squared times dx equaling y cubed minus 3x squared y times dy, right? A technique over here is that they have not asked you for it to be proved by any specific method, right? You just have to prove that this is a general solution. So you have the flexibility to choose any method that you want, right? But usually speaking, differential equations can only be solved by very specific, right? It's either one or two methods that you use to solve any given differential equation, or not all. Because reduction to any other method basically takes a lot of time, right? And it's a lot of effort for a very long operation. All right. So here, what I do is basically split this up as x cubed dx minus 3xy squared dx, right? Equaling y cubed dy minus 3x squared y dy, right? So you and then bring these two terms over here. This is basically x cubed dx minus y cubed dy equaling 3xy squared dx minus 3x squared y dy, right? So basically this is this I can further rewrite it as x cubed dx minus y cubed dy equaling 3xy times y dx minus x dy, right? Remember that you have some you can bring this form by using this elementary the differentiation of this elementary thing, right? I should not write this as d of, if I write this as d of y by x, right? This is the differential of a function with respect to nothing, right? So you're basically going to have, this is if you remember dy dx of y by x, this is basically y dash, right? Divided by x minus y divided by x squared. Or basically this is x y dash minus y by x squared, right? So if you want to write d of y by x, you'll basically have x dy minus y dx divided by x squared, right? Because you're basically going to multiply this over here. Basically, that's it, right? Because that's your Leibniz rule, right? So you have this form, right? And you can see that the numerator is basically what is here, right? With a minus. So, right, now if you do that, then you lose this form, right? So basically, no, it doesn't work out. For the try. Anyway, so it would have worked if it was a plus over here, right? Then it'll be d of xy and you can just directly integrate over here. But yeah, whatever. So we can do this. So basically we'll have to do the variable separable form. Right? Variable separable, no. This is homogeneous, right? So what you do is you basically bring it to your homogeneous form. That is this is y dash equaling this dy by dx equals x cubed minus 3xy squared divided by y cubed minus 3x squared y, right? Divide the whole thing by x cubed and do the substitution y equals vx. So you're going to get v plus x dv by dx equaling, this is 1 minus 3 times v squared divided by v cubed minus 3v, right? So bringing this to the other side, this is minus v. And so you're going to basically have 1 minus v power 4 minus 3v squared plus 3v squared divided by v cubed minus 3v, which is basically this 1 minus v power 4 by v cubed minus 3v. That is x dv by dx, right? And so you are going to have dx by x equaling dv into v cubed minus 3v divided by 1 minus v power 4, right? Or you basically have this ln mod x equaling integral of v cubed dv by 1 minus v power 4 minus 3 times the integral of v into dv by 1 minus v power 4, right? This is a simple integral. Take this whole thing, substitute this whole thing as t, you'll basically get the answer, right? Yeah, no. Instead of doing this way, we can basically take this as partial fractions, right? So just do it over here. I'll just do the partial fractions here. This you can rewrite this as v cubed minus 3v divided by 1 minus v into 1 plus v into 1 plus v squared, right? Because it's 1 plus v square and 1 minus v square, and 1 minus v square is 1 minus v into 1 plus. So you have this. So your partial fraction forms are going to be a by 1 minus v plus b by 1 plus v plus cx plus d by 1 plus v squared, right? cv plus d, whatever, right? Do all the substitutions, do everything, do every everything that you're going to have to do to get this form and to match this. And basically, you're going to finally end up with a being minus half, b being plus half, right? Yeah, are going to be 2 and 0 respectively, right? For things. Basically, you're going to end up with integral of half integral of dv by 1 minus v. Wait a minute. It's half integral of 1 plus v minus half integral of integral of dv by 1 minus v, right? Plus integral of 2v dv by 1 plus v squared, right? Which is basically half of ln mod 1 plus v plus ln mod 1 minus v, right? 1 minus v plus ln mod 1 plus v squared, of course, and the constant, right? Wait a minute. This should be a minus. This should be a minus. So this is a minus, right? And so you basically have half ln mod 1 plus it's 1 minus v squared minus ln mod 1 plus v squared plus c, right? Therefore, you basically have the equation cx equals root over 1 minus v squared by 1 plus v squared, or the fact that cx, or you basically have that cx is equal to square root of 1 minus y squared by x squared divided by 1 plus y squared by x squared, right? Multiplying the whole thing, rationalizing this basically, this is going to be, this is x squared plus y squared, and over here you multiply by x squared, right? And so you basically have cx times x squared plus y squared equaling, this is x times square root of x squared minus y squared, or this x and this x cancels out, of course. And so you basically have c squared, that is also another constant c, times x squared plus y squared, the whole square, equaling x squared minus y squared. And that is the given solution, right? What kind of an exact form would this? Where this whole thing is good. Yeah. So that completes your question number 4, right? Question number 5. Differential equation of the family of circles in the first quadrant which touch the coordinate axis, right? Which touch the coordinate axis. So basically, if the center of the circle is x comma y, let's say, that's a center, then basically your radius is going to be equal to x is going to be equal to y, right? So your center is basically equaling r comma r. The equation of such circles is going to be x squared plus, wait a minute, this is x minus r the whole square plus y minus r the whole square equaling r square, where r is a real, right? And so just basically expand this, you get x square minus 2rx plus y square minus 2ry plus r square equaling 0, right? That's the equation that you're going to be working with. Differentiating this once, you basically get 2x minus 2r plus 2y dash minus 2ry dash equals 0, right? So we basically have y dash, okay, not y dash, you have to get r from this side. So we basically have minus 2r times y dash plus 1, right? Or I'll just take this to the other side, equals 2x plus 2y dash, right? Just removing all 2's, we basically have r equals x plus y times y dash divided by 1 plus y dash, right? And so we basically substitute this r over here and get the fact that it's x squared plus y squared minus 2 into x plus y dash by 1 plus y dash times, this is x plus y plus x plus y dash by 1 plus y dash the whole square equaling 0, right? And this, this form is pretty complex, right? This form is very complex. So what you can do instead is basically substitute in the first equation, this point, right? Where you get x minus x plus y dash by 1 plus y dash the whole square plus y minus x plus y dash by 1 plus y dash the whole square equaling x plus y dash by 1 plus y dash the whole square, right? Just taking this common, you can see that this x and this x will cancel out. And so here you're basically left with xy dash minus y dash divided by 1 plus y dash the whole square, right? The same way over here, you can see that this y dash and this y dash will be cancelled out. And you're basically left with y minus x by 1 plus y dash the whole square equaling x plus y dash divided by 1 plus y dash the whole square, right? Since the denominators are all the same, you can basically cancel it out because they are not 0, because y dash is a function and not exactly a constant, right? So you're finally left with x squared y dash squared minus y squared y dash squared, this plus, right? Minus 2xy y dash squared, right? Plus x minus y the whole squared equaling x squared plus y squared y dash squared plus 2xy y dash. Or since this is basically x minus y the whole square into y dash squared, this side LHS is basically x minus y the whole square into 1 plus y dash the whole square equaling x plus y dash the whole square, right? And this is a perfectly valid and a pretty simple differential equation, right? This is your answer. That's question number 5. Question number 6. Find the general solution of the differential equation y dash plus square root 1 minus y squared by 1 minus x squared equaling 0, right? What this is basically your variable separable method, right? So I'm going to directly skip steps. I'm going to basically write dy by root of 1 minus y squared plus dx by root of 1 minus x squared equals 0, right? Taking this to the other side, cross multiplying and then bringing it back, all right? And integrating on both sides, 0 basically becomes a constant, right? This is, if you remember your integrations correctly, this is sine inverse of y, this is sine inverse x, this is your solution, right? Very simple, 3 steps, that's it. Question number 7. Show that the general solution of the differential equation this is given by this, where a is a parameter, right? This again is your variable separable method. The same way as this, I'm going to skip steps over here. This is basically dy by dx plus y squared plus y plus 1 divided by x squared plus x plus 1 equaling 0, right? And so we can basically write this as dy by y squared plus y plus 1 plus dx divided by x squared plus x plus 1 equaling 0, right? This then basically becomes, if you integrate on both sides, this basically becomes a constant. Remember your integration, folks. This is basically, you can write this as dy by y minus over here. Since I'm again writing the integration symbol, this becomes a 0. That's not a constant over here. So this is y plus this is y plus half the whole square plus 3 by 4, right? And this is again, this is dx by x plus half the whole square plus 3 by 4, right? And so you can basically write this. Yeah, this is dy by a square plus x square, right? This is dx by a square plus x square. And this is basically a times, that is root 3 by 2 times tan inverse of x by a, right? Similarly, this becomes root 3 by 2 tan inverse of y plus half divided by root 3 by 2 equals a constant, right? All right. Now, basically, I'll just cut this off because this going to the other side. This becomes 2c by root 3. That's also another constant c. So whatever, right? Who cares? Right. So you're basically left with tan inverse A plus tan inverse B. I hope you remember the formula. That's tan inverse of A plus B divided by. So that's basically x plus y plus 1 divided by this whole thing is divided by root 3 by 2, 1 minus AB, right? That is x plus half into y plus half divided by 3 by 4, right? This cancels out to give root 3 by 2. And since this is equal to a constant, right? So you can basically remove this because tan of this and tan c is again going to be a constant, so we don't need to change the right hand side. So basically, we have the fact that x plus y plus 1 is equal to this constant a. Wait, I'll just make this tan c. All right. Let tan c equal some constant, some parameter a. So x plus y plus 1 is equal to a times 1 minus, this is xy. Wait a moment. What am I doing wrong? Just a moment. This is a plus b divided by 1 minus ab, right? So yeah, just get it out. Oh wait. I can't do this without multiplying this also by root 3 by 2. Right. This becomes root 3 by 2 minus this divided by root 3 by 2 again. Right. This is xy plus x plus y. This half. This is x by 2, y by 2 plus 1 by 4. Right. And cross multiplying and taking this out, this becomes a divided by root 3 by 2, which is another constant a, right? But I don't care right now. I'll write that at the last. This is 3 by 4 minus, this is xy minus x by 2 minus y by 2 minus 1 by 4, right? And taking this taking this 4 outside, this basically becomes a by 2 root 3 into 3 minus, this goes here and this becomes half, right? So I'll just take the 2 outside. I'll take this 2, this 2, this 2, and here into 2 divided by 2, this 2. I'll take it common out, right? This becomes root 3, and this becomes, instead of 3, this is going to be 1. It's going to be 1 minus x minus y. This is going to be, this is also going to be minus 2xy, right? Since a by root 3 is also a constant, we can basically write this as a parameter a. And so x plus y plus 1 equals a times 1 minus x minus y minus 2xy, right? Since you have this shown is verified, right? Remember that a constant, this arbitrary constant divided by any constant term is again a constant and can be represented by the same letter because it does not make a difference. All right. There is just a semantic difference. There is nothing else. Question number 8. Find the equation of the curve passing through the point 0, 5 by 4 whose differential equation is sin x cos y dx plus cos x sin y dy equals 0. All right. So this is a variable separable form, right? I'll basically write this first as cos x sin y dy equaling minus sin x cos y dx, right? So cos y goes down, sin y goes down, right? Cos x goes down, cos x goes down. And so you basically have this equaling tan by dy, because it's sine by cos, it's tan by dy equaling minus tan x dx, right? Or this is basically tan by dy plus tan x dx equaling 0, right? Integrate this. This is basically log mod secant x into secant y equaling a constant. So basically, this is secant x into secant y equaling a constant. Or you can also rewrite this as this is pretty much equivalent to cos x cos y equaling a constant. All right. And so since this curve passes through the point 0, pi by 4, right? You basically have this to be 1 into 1 by root 2 is equal to c, or c is equal to 1 by root 2. Therefore, your particular solution then becomes cos x times cos y is equal to 1 by root 2, right? Or you can also rewrite this as secant x and secant y is equal to root 2, whatever, right? Or some other form like secant x is equal to root 2 cos y or something like that, right? It does not matter. This is basically your particular situation, right? Question number 9. Find the particular solution of the given differential equation 1 plus e power 2x into dy plus 1 plus y squared into e power x dx equaling 0, given the point 0, 1, right? So basically, this is again a variable separable form, right? I'm going to basically divide this by 1 plus y square and 1 plus e power 2x, right? So this basically becomes, this is basically equivalent to dy divided by 1 plus y square plus e power x dx divided by 1 plus e power 2x equaling 0, right? Let e power x equals t, right? Then this term is basically dt divided by 1 plus t squared. So you basically have this to be, this differential equation then becomes dy by 1 plus y squared plus dt by 1 plus t squared equaling 0. And if you integrate this basically becomes tan inverse of y plus tan inverse of t, or I'll just substitute t over here, tan inverse e power x is equal to a constant. We have this to be your general solution, your GS, right? Given the point 0, 1, this is basically pi by 4 plus pi by 4, pi by 4 plus pi by 4 equaling c, or c is equal to pi by 2. Therefore, your particular solution becomes tan inverse y plus tan inverse of e power x equaling pi by 2. Right, that's your answer. Cool. Going to the 10th question. Question number 10. Solve the differential equation y into e power x by y dx is equal to x into e power x by y plus y squared times dy, right? First of all, notice that you have an x by y up on top and you can't separate this out. So basically, this is going to be a homogeneous equation of the form dx by dy equals something, right? That is going to be what you have to get, right? So I'm basically skipping some steps and directly writing this form. This is basically dx by dy equaling x e power x by y plus y squared divided by y e power x by y, right? And so basically, wait. Now we'll make the substitution x equals vy. This is notice that this is not exactly homogeneous, right? This is not a homogeneous. This is not homogeneous. But you can basically solve this by x equals vy because of this this special form of e power x by y, and basically this is the only way we have to solve this kind of an equation, right? So we have to try this out. And if you don't get it, we have to do something else like brute force. There's nothing to it. All right. So we have x equals vy. And we know what this dx by dy then becomes, right? This is basically v plus y dx by v plus y dv by dx, right? All right. Y dv by dy. I'm sorry. Right? So this is equal to, this then becomes x times e power v. Wait, this is, instead of x, we have to write vy times e power v plus y squared divided by y into e power v, right? This y, 1 by goes off. So basically, do a minus v over here. This becomes, this is v e power v plus y minus v e power v. So basically this and this cancels off, right? And so you are left with y dv by dy equaling y by e power v. Y and y cancels off. You are basically left with e power v dv equals 1 dy, right? Or e power v is equal to y plus c, right? Therefore, you have the solution e power x by y is equal to y plus c. That's your answer, right? Question number 11. Find a particular solution of the equation x minus y times dx plus dy equals dx minus dy. Right. First of all, for these kinds of questions, what I like to do is notice that this form and this form can be, can be obtained from very specific functions, right? So, for example, if you take the differential coefficient of x minus y with respect to nothing, you basically get dx minus dy, right? Similarly, if you take the function d of the function x plus y and differentiate it with respect to nothing, you basically get this as dx plus dy, right? So, right, let x minus y equals t, x plus y equals u, right? This means that this is basically dt, this is basically du, right? So we have t du equaling dt. So this becomes du equals dt by t. Integrating on both sides, you basically have u is equal to ln mod t plus c, or basically that e power u is equal to c times t, or the fact that e power x plus y is equal to c times x minus y. Right? Given that when y is equal, x is equal to 0, y is equal to 1. So we have the point 0 comma minus 1. Substituting that over here, you basically have e power minus 1 is equal to c, or basically e power x plus y plus 1 is equal to x minus y, right? That's your particular solution. All right. Or ln mod x minus y is equal to x plus y plus 1, whatever. Again, same equation expressed in different forms, right? That's 11. Question number 12. 12 is solve the differential equation e power minus 2 root x divided by root x minus y by root x into dx by dy equals 1. All right. Basically, I'm going to convert this to dy by dx equals some form, right? And then I'm going to make this a linear equation, right? So y dash plus 1 by root x times y is equal to e power minus 2 root x divided by root x. That is basically what this equation is. So your integrating factor is going to be e power integral of 1 by root x dx. That is basically root x by 2, right? Right. This is root x by 1 by 2. That's 2 root x, 2 root x, 2 root x. So we have the integrating factor to be, wait, I try this properly. This is basically integrating factor equaling e power 2 root x, right? Therefore, your solution is going to be y e power 2 root x is equal to integral of e power minus 2 root x into e power 2 root x is going to be 0, which is going to be 1. And so you basically have dx divided by root x. That is basically 2 root x. So your y e power 2 root x is equal to 2 root x plus c is going to be your solution, right? If you want, you can basically write this as y equals e power minus 2 root x into 2 root x plus c, but again, same form, right? I'm not bothering with that. Question number 13. Find the particular solution of the given differential equation y dash plus cot x times y equals 4x cosecant x, right? Given the point pi by 2 comma 0. So basically, over here again we have the same old linear form. Where integrating factor is going to be e power integral of cot x, that is equal to e power ln mod sin x, right? This is equal to sin x. Forget the mod because we are basically restricting our domain to x equals minus pi by 2 to pi by 2 because we have the given point pi by 2, right? So yeah, therefore the solution then becomes y sin x equaling integral of 4x cosine x into sin x, and sin x cosec x is 1 because cosec x is 1 by sin x. Therefore, this is equal to integral of 4x, that is equal to 2x squared, right? Therefore, y sin x equals 2x squared plus c, right? That's the general solution. Since we have a particular point pi by 2 comma 0, what we do is here it's 1 into 0 is 0, here it's 0 is equal to pi squared by 2 plus c, or c is equal to minus pi squared by 2, right? So you have y sin x equaling 2 times x squared minus pi squared by 2. This is a particular solution that you're looking for. That's the answer, right? Then question number 14. Find a particular solution of the differential equation x plus 1 into y dash equaling 2 e power minus y minus 1. Given that it passes through the origin 0, 0. Right. Pretty simple to see that this is variable separable again. And so I can basically rewrite this as this is a dy divided by 2 e power minus y minus 1 equaling dx divided by 1 plus x. Right. This again, notice that this can be written as e power y dy into 2 minus e power y. But basically, this is dt by 2 minus t, something of that sort, right? So that is minus ln mod 2 minus t, right? This is basically minus ln mod 2 minus e power y equaling ln mod 1 plus x plus c. But basically, this is 1 by 2 minus e power y equaling c times 1 plus x, right? Since it passes through the origin, we have the fact that 1 is equal to c. Therefore, you have the formula, you have the equation 1 plus x, the 2 minus e power y is going to be equal to 1. That is a particular solution. This is a general solution, right? This is the answer. Well, 1 plus x into 2 minus e power y is equal to 1. Right? That's 14. 15 says that the population of a village increases continuously at a rate, of course, I have to write it down, right? Y is the population of the village, POPL, population, X is going to be the time, all right? And so we have dy by dx is equal to, is proportional to the number of inhabitants present at any time. So it's going to be some constant k times y, right? We have, so this basically gives us, this is 1 by k ln mod y equals x plus c, right? Solving this equation gives you this. because I bring y down, bring this x up. So basically it's 1 by k down y is equal to x plus c. Or if you don't want to deal with this 1 by k, basically do this ln mod y is equal to kx plus c. Right. This is your general solution. Right. You basically have two data points of this 1999, 20k and 2004, 25k. Right. And so using these two, we can find out k and c. Right. And we have to basically plot what is the figure in 2009. All right. So first of all, notice that this is ln mod y equals kx plus c. And so ln mod 20,000, it is 0 extra. 20,000 is equal to k into 1999 plus c. Right? Ln mod 25,000 is basically k into 2004 plus c. Right? Subtracting both, we have 5k is equal to ln mod 5 by 4, ln of 5 by 4, right? Or basically k is equal to 1/5 of ln of 5 by 4. All right. So from this we can find out c, or we actually don't need to find out c. If the value of the population is p at in 2009, then we basically have ln of p divided by 20,000 is equal to 10 times k, right? Because it's going to be k into 2009 plus c, right? And so if I do this minus this, then I'm going to get this equation. So having this, since I know the value of k is 1/5 of ln of 5 by 4, this is basically twice, or this is basically 2 into ln 5 by 4, right? Which is ln of 25 by 16. So basically, p is equal to 20,000 into 25 by 16. That is equal to 31,250. That's your answer. Right? 3 questions left. 16. The general solution of the differential equation y dx minus x dy divided by y is equal to 0 is very simple. Right? First of all, notice that I've already told you y dx minus x dy divided by y squared is basically minus d of x by y, right? Because this is if you do d by dy of right, yeah, it's not right here. If I do d by dy of x by y, I'm going to basically get x. This is dx by dy divided by y minus x divided by y squared, right? This is basically going to be y dx by dy minus x divided by y squared, right? Bringing the dy over here, and basically we're going to get y dx minus x divided by y squared. Right? So this plus, this one minus, sorry, that, right? And so we basically have this. Therefore, y dx minus x divided by y is 0 is basically y into d of x by y equaling 0, right? Instead of this, just basically do your normal integration. Dx minus is too complicated, right? X by y dy is equal to 0. So basically, dx by x minus dy by y equals 0. But basically, x into y is equal to constant c, right? Easier answer to this. Oh, wait a minute. What am I even doing? This is x by y is equal to c, or x is equal to c times y, right? That's the solution. X is equal to c times x is equal to cy, or y is equal to cx, whatever. C is your answer, not a, right? You can also get it from here, because basically cut this y out, right? This is a differential term. This cannot be always equal to 0, right? So if this is equal to 0, then this has to be 0. So basically, wait, this is 0. This into this is 0. So this is 0. This cannot always be 0. So if this is 0, integrating over here, you basically get x by y is equal to c. And so x is equal to cy. From this you can get over here and bounce around. That's it. C is your answer. Right? 17. 17 goes like the general solution of the differential equation with the type dx by dy plus p1x is equal to q1. Theoretical question, right? This is basically y into the integrating factor is equal to integral of q times the integrating factor, right? So basically the integrating factor is e power p1x, e power integral of p1x, p1 dx, right? It's, wait, p1 is a function of y, right? P1 is a function of y. P1 is some f of y. So basically you have to do p1 dy. It's either a or c from here, right? And you basically know that it is this form is for us an x into e power some y term, right? So the answer is C, basically. Yeah, that's fine. You have to just eliminate your answers accordingly, right? This is theory. This is just theory which is stated up, but they've asked because you need to remember it. Finally, coming to the last question in this chapter, that's e power x dy plus y e power x plus 2x dx equals 0, right? What do you do over here? Basically check that this is e power x times dy plus y into e power x times dx plus 2x dx equaling 0, right? Notice that this is basically the differential coefficient of e power x times y, right? Because this is e power x into dy plus y into d of e power x, right? That is e power x dx. So you basically have d of e power x, d of e power x y plus 2x dx equaling 0, right? And integrating on both sides, you basically have this is 0, right? So integrating on both sides, you basically have e power x y plus x squared equaling a constant c, right? This is x. So this is y e power x plus x squared equaling a constant. Again, the option is C. All right, and thus ends the chapter differential equations. Hope it was clear and hope you all learned something properly. Right. Thank you. Have a nice day. And this is Anirudh signing off.